Recording in progress. Hi students, in the last class we have done calculation for circular arc, plate and hemispherical shell. Now let us continue. Fourth one is solid hemisphere, not sphere, because if you take sphere, center of mass will be at center. Okay, this is solid hemisphere. See calculation part. So coming to calculation part, see diagram. So this is a solid hemisphere. So here, if you imagine line of symmetry, center of mass will be on the line of symmetry. So this one we can solve in two different ways. One is, this is a combination of plates. If you cut into slices, cut parallel to base, okay? If you cut a parallel to base, we get plates, circular plates. And for each plate, center of mass will be at its center. This is a combination of plates. Next one, it is a combination of hemispherical shells. It is combination of hemispherical shells. If you want to use that, see what we can do. I am imagining here one hemispherical shell of radius small r, this width equal to dr. Okay, and for spherical shell means hemispherical shell, center of mass is at a distance r by 2 from the base, right? R by 2. So I can replace this entire spherical shell means hemispherical shell with a point mass at its center of mass. I am repeating, we can replace this hemispherical shell with a point mass at its center of mass. So right here, YCM is equal to integral y dm upon integration of dm. So in the place of y, it is r by 2 because center of mass for hemispherical shell is r by 2. Next, in the place of dm, I am going to write here volume is in the entire, in here mass is in the entire volume. Okay, so we have take mass per unit volume, that is rho. Corresponding area, I will show here mass corresponding to this shared part. That mass we have to focus. Okay, that mass we have to focus. See how to find it. That corresponding volume. Okay, corresponding volume. I will show calculation here. It is half sphere, right? Therefore, volume will be 2 by 3 pi r plus dr whole cube. This is outer volume. Subtract from this inner volume. Then we get this part of the volume. Okay, because we want to calculate mass of that volume only, right? See how much we get. This is now dV. That is equal to 2 by 3 pi, expand this, a cube plus b cube plus 3a square b plus 3a b square dr whole square minus r cube. So here dr cube very small, dr square very small. We can neglect those two. Remaining r cube gets cancelled. What is left here? 3r square dr and 3 gets cancelled. Remaining is 2 pi r square dr. So we have taken only for half spherical shell, okay, hemispherical shell. That's why getting it. And keep this point in mind because we are going to use frequently this result. So here rho into 2 pi r square into dr. Okay. Now see the calculation part. Substituting that. Substituting that to see what we get. R by 2 YCM equal to integration of R by 2 in the place of dm. You can see rho is a constant, 2 pi is a constant, rho constant, 2 pi is a constant, r square dr. I am taking remaining r square dr, r square dr upon again r square dr. So take 1 by 2 outside, r square r cube. R cube means r power 4 by 4, right? Next r square, r power 3 by 3. See what we get? R cube, r power 4 remaining is r. It becomes now 3r by 8 because limits are 0 to capital R. We have to take all hemispherical shells. Okay. That means distance of center of mass from the base is 3r by 8. Okay. Let us see next solid cone. How to calculate. So coming to solid cone, see how to make calculations. Let us make a diagram. And it's a vertex. So again, here we can take line of symmetry. Line of symmetry. Line of symmetry. Center of mass will be on the line of symmetry. Let us take it as y-axis. See, since it is now cone, if you cut into slices like this, if you cut into slices, we are going to get circular plates. Okay. So I'm taking here from vertex at a distance y, at a distance y, take a small thickness dy. Means we are getting a circular plate of thickness dy. And for this plate, center of mass will be at its center. Okay. So what I can do here, YCM equal to integral y, it is y only, in the place of dm. Here mass is in the entire volume. So we should take dm equal to rho into dv in the place of dv. See what we can write. If radius is r, if radius is r, area pi r square, its thickness is dy. Area into thickness, volume. Volume into mass per unit volume. This is dm. Okay. Now that we can substitute here. That we can substitute here. Rho into pi r square dy upon again rho into integration of dm, right? Rho into pi r square dy. And we can see carefully y is variable, r also variable. So we have two variables, right? When you are changing y, r also change. So we have to convert this into single variable. We have to convert this into single variable. That means we have to connect y and r. See from diagram what we can do. If base radius equal to capital R and height equal to h, okay, then I can write y by h is equal to r by capital R, right? See once y by h equal to r by capital R. So in the place of small r, see what we can write. It is y into capital R upon h. This is what we have to substitute. Yes, sir. And in this, see what else we can do here. If you observe capital R, it is a constant. H also constant. So since these two are constants, anyhow, they will cancel here, right? They will cancel here. That means I can say here R proportional to Y because R and H constants. So I will write here rho gets cancelled, Y gets cancelled, remaining integration of Y R proportional to Y. So R square proportional to Y square. So Y into Y square, sorry, Y square dy upon Y square dy. Okay. So Y and Y square, Y cube. It becomes Y power 4 by 4. Y power 4 by 4. Next, Y cube. Y power 3 by 3. Now take limits. Taking plates like this from y equal to 0 to y equal to h. 0 to h. Okay. That means y cube and y power 4. Y is left 3h by 4. Okay. So center of mass of a solid cone is at a distance 3h by 4 from the vertex. Let us see next one. Next one is a hollow cone. Hollow cone. Since we have done for solid cone, it becomes now more simple. Almost same kind of calculation. This is now hollow cone. Hollow cone. Center of mass will be on the line of symmetry. If you cut this into slices, we are going to get rings, combination of rings. And for each ring, center of mass will be at its center, right? At its center. So I am taking same as the previous one at a height y. Take now one ring. Okay. This gap equal to dy. Well, this gap. Next, see what we can do. Coming to YCM. Integral y dm upon integration of dm. Y means y only. But while taking dm, since it is now hollow, mass will be only on the surface, not in the volume. So we have to consider it is mass per a unit area. Otherwise, see what we can do here. Mass per unit volume. Sorry, mass per unit area, right? See what is the area of this ring? I can take dm is sigma into because mass is only on surface. That's why taking mass per a unit area. Coming to for ring, if radius is r, its area will be length is 2 pi r, Now see carefully in diagram for the ring width equal to it is not dy. Suppose I am taking this angle is theta. I am making diagram separately here. This angle is theta. This is now dy. This length is dy. Okay. Now this length is how much? That length will be dy by cos theta. Because when you cut into slices, we get rings. But for the rings, edge is not vertical. That edge is slant. That slant length is dy by cos theta. So 2 pi r into 2 pi r into dy by cos theta. Okay. Next, when you are taking here theta constant, sigma constant, 2 pi also constant, 2 pi sigma and a cos constant. Remaining is now r dy. So I'm taking directly here y in the place of dm, r dy upon r dy. Okay. Again here r is variable, y also variable, having two variables. So we want to convert this into single variable. Again, taking the same result, same as the previous one, it is y by h equal to what is h? This is total height equal to h, base radius equal to r. So y by h equal to r by capital R. So in the place of r, what I can write? R by h into y. R is a constant, H is a constant, R proportional to Y. Same logic we got in the previous also. R proportional to Y. So in the place of R, I am writing Y because remaining cancel, right? R, H cancels while writing here. So Y into Y square dy upon it is Y dy. It becomes Y cube by 3. That is Y cube by 3. Y square by 2, y square, and here y square gets cancelled. Remaining is now 2h by 3. So in case of a hollow cone, center of mass distance from the vertex is 2h by 3. Okay, right. Let us take one problem. Read the question carefully. A paraboloid shaped solid object is formed by rotating a parabola y equal to 2x square about y-axis as shown in the figure. So this is a parabola, okay? No? If we rotate this, the shape what we are going to get, that is what we call paraboloid. And equation of this parabola is given by y equal to 2x square. If height of the body is h, its meaning is from here to up to here. This is h, okay? Then the position of center of mass from origin, and condition is assume the density of the body same throughout. Okay. Given y equal to 2x square. Distribution of mass is continuous. So far we have taken right elements. Now same logic here also. How to take elements? Last question. How we are taking elements? Given y equal to 2x square, right? So here what I am doing is, if you cut into slices, we are going to get plates, right? So for each plate, center of mass will be at its center. Getting it? Now what I am doing here, take at a height y, take a plate of thickness dy. Okay, that means we can see it is just like a cone, right? Shape is different. Okay, shape is different. For this, how to find mass is a question mark. See, YCM by symmetry. Center of mass will be on the line of symmetry. Iteration of YDM upon iteration of DM. So Y means Y only, but focus now DM. How we get DM? Here mass is in the entire volume. Mass is in the entire volume. So we have take mass per unit volume. So rho into corresponding volume. This is now one plate, right? For this plate, what is area? Area is now pi r square. R is nothing but x, okay? Plus x is nothing but r. So pi r square means pi x square, that is area, into thickness dy, that is volume. This is giving us dm. Okay. Now in this we can see variables are x is variable, y also variable. Okay. Then see what we can do here. We have to get in terms of h. Means I have to eliminate y, right? So here we can do one thing. In the place of x square, we can write y by 2. So pi constant, rho constant. In the place of x square, y by 2 into dy, right? That is dm. So while taking dm, I can, pi gets cancelled, rho gets cancelled, 2 also gets cancelled. Simply y dy, right here. Integral y in the place of dm, y dy. Because remaining are constants, they get cancelled. Integration of y dy. But students, you should not cancel y and y because y is variable. Take limits 0 to h. Okay. Y square dy, y cube by 3. Y square dy, y cube by 3. Y dy, y square by 2. Y square by 2. Now take limit 0 to h. We get 2h by 3. So just taking elements properly, we can get all answers, right? I hope you got a clarity.